For this set of slides, we will be talking about the effect of exercise on hydrogen ion concentration, or pH. Our first question is, where do hydrogen ions come from during exercise? You should know that there are three main sources of hydrogen ions during exercise. The first is the production of carbon dioxide during aerobic ATP production. The second is the production of lactate during anaerobic ATP production. And the third is from the breakdown of ATP. During aerobic production of ATP, carbon dioxide is produced as a byproduct. This carbon dioxide can react with water to form carbonic acid, which can then be dissociated into a hydrogen ion and bicarbonate. If this sounds familiar, that's because I just described the bicarbonate system that we discussed earlier in this chapter and in the previous chapter as well. Again, you don't need to memorize the bicarbonate system equation, you just need to be familiar with what it does. At the end of anaerobic ATP production, or at the end of glycolysis, we produce pyruvate. If we produce pyruvate so quickly that we overwhelm the body's capacity to use this pyruvate to produce ATP aerobically, the excess pyruvate will get converted into lactate, which produces a hydrogen ion. And finally, the breakdown of ATP can also produce a hydrogen ion. Our next question is, how does the pH of the body change during exercise? On the previous slides, we discussed three ways that the body can produce hydrogen ions during exercise. Because the pH of the body is determined by hydrogen ion concentration, this increase in hydrogen ion concentration that we see during exercise can lead to a decrease in pH in various areas of the body. As you can see from this figure over here, the pH of the muscle is going to go down as the intensity of the exercise goes up. Likewise, the pH of the blood will also go down as exercise intensity increases, and this is particularly the case when we're talking about higher intensities of exercise. So generally speaking, increasing exercise intensity is going to cause hydrogen ion concentrations to go up, which causes the pH to go down. You'll notice that the pH of skeletal muscles goes down very rapidly compared to blood pH, and this is because, as we mentioned before, muscle has a limited capacity to buffer the hydrogen ions that are produced. So it's very easy to overwhelm this capacity with intense exercise, and that has a very dramatic effect on pH. In contrast, blood pH tends to stay very constant at lower intensities of exercise, and you don't start to see a decrease in the pH of the blood until higher intensities of exercise. It's also important to note here that the change in pH that we see is going to be dependent upon the exercise intensity, which you can see from these figures. At higher intensities of exercise, we see a bigger decrease in pH. It's also going to depend on the duration of the exercise, so it takes a little bit of time before your body's buffering capacities are overwhelmed. The sweet spot is really 45 seconds, so if you exercise less than 45 seconds, you generally tend to be able to accommodate the hydrogen ions that are produced before they cause drastic changes in blood pH. If you exercise for longer than 45 seconds and you're exercising at a very high intensity, you're more likely to overwhelm the capacity of your body to buffer hydrogen ions, and that would lead to possibly acidosis. And the final thing that's going to affect pH change is the amount of muscle involved. So if I'm doing maximal finger exercises, I'm only using a very small mass of muscle, and that very small mass of muscle isn't going to be producing enough hydrogen ions to have a huge impact on blood pH. In contrast, if I'm doing maximal leg exercises, like a very, very, very heavy leg press or something, that large mass of muscles is going to be able to produce a lot more hydrogen ions. I have a much bigger chance of producing a change in my blood pH. And that leads us really nicely into our next question, which is, what type of exercise is most likely to disrupt acid-base balance? Well, as we alluded to on the previous slide, you're more likely to have an acid-base disturbance if you're doing high-intensity exercise that lasts 45 seconds or longer. Your risk of acidosis is also going to be affected by competitor effort, and what this means is if you have two athletes playing, say, soccer, and one athlete is trying really hard and one athlete is just kind of wandering around the soccer field, not really playing very intensely. That soccer player who's working really hard to perform well in the soccer match is going to be at an increased risk of acidosis compared to the athlete who's just kind of wandering around the soccer field. The risk of acidosis is also increased in events with prolonged sprints to the finish. So generally speaking, a 5K run or a 5,000 meter run isn't the duration that we typically see causing acidosis unless the athlete sprints to the finish. And so these longer duration activities that you generally think of as more aerobic can have a very anaerobic component, and that anaerobic component at the end, or the sprint to the finish, can dump a lot of hydrogen ions into the blood, leading to an increased risk of acidosis. So if you look at this slide, the activities that are marked with a orangish star, those are activities that are going to be affected by competitor effort in terms of the risk of inducing acidosis, and then the activities that are marked with a blue star are going to be activities where we tend to see a more prolonged sprint to the finish that could lead to an increased risk of acidosis. So why do we want to maintain acid-base balance during exercise? I already kind of alluded to this concept at the beginning of this chapter, but we'll revisit it again because it's really important. Acid-base disturbances are important to watch out for because they can have a very negative impact on performance. If you have a drastic increase in hydrogen ion concentration or a drastic decrease in pH, that is going to cause the muscles to fatigue. Why does fatigue occur? Fatigue occurs because these hydrogen ions are going to inhibit the activity of enzymes that are involved in the production of ATP, and these hydrogen ions are also going to compete with calcium for binding sites on troponin. So remember, troponin is a part of the thin filament, and normally calcium binds to troponin, and that causes tropomyosin to move and expose an active site on actin. If hydrogen is present in the muscle in a high enough concentration, it can bind to the calcium binding site on troponin instead of calcium, so it essentially outcompetes calcium for the binding site. If hydrogen binds to troponin instead of calcium, we don't see tropomyosin moving to expose the active site on actin. If you don't expose that site, then actin and myosin aren't able to interact, and you won't be able to have cross-bridge cycling occur. And so there's two different ways that we've shown that this increase in hydrogen ion concentration can have a negative impact on performance. It can affect ATP production, and it can affect cross-bridge cycling. Our final question is, can you improve athletic performance by increasing one's ability to maintain acid-base balance? There has been quite a bit of research done in this area, trying different strategies for increasing the blood buffering capacity. There is evidence to suggest that consuming sodium bicarbonate and sodium citrate in high enough doses can increase the buffering capacity of the blood, leading to an increase in performance in high-intensity events. However, it's important to note that consumption of these products can lead to nausea, vomiting, diarrhea, and even headaches, which may have a negative impact in performance. It's also worth noting that some sport regulatory bodies have banned consumption of products that may increase performance by altering blood buffering capacity. So if you are an athlete, I wouldn't necessarily recommend consuming things like sodium bicarbonate or sodium citrate to try to improve performance, because you never know if it's going to cause those unfortunate GI side effects. And you also could have some concerns about whether or not it would affect your eligibility to participate in certain events.